For this project goal, we aimed at predicting the net hourly electrical energy output of the power plant based on four environmental conditions. The first being temperature, exhaust vacuum, ambient pressure, and relative humidity. For this task, this is a regression problem because the output is a continuous number. The first step that we did was load and inspect the data. We loaded the data set with the 9,500 rows and 5 columns, all numeric with no missing values. And the target variable was PE, or the net hourly electrical energy output. The next thing that we did was we split the data set into 80% for training and 20% for testing. This allowed us to train the models on one set of data and evaluate their performance of unseen data. Then we went ahead and selected 2 common regression models, the first being a linear regression, and the second was a random forest regressor. For the linear, it was a simple interpretable model and assumed the relationship between the features and the target. For the random aggressor, it was a kind of ensemble model based on decision trees. And for this model, it also handles nonlinear relationships and interactions between variables fairly well. The next thing that we did was we did some cross-validation to compare the models. We used a 5-fold cross-validation on the training set. So this divides the training into 5 parts and trains on 4, and then validates on the 5th, repeating this 5 times. We computed the root mean squared error as our evaluation metric. For our results for the linear regression, we ended up with 4.57. For the random forest model, we ended up with 3.46. So the random forest model predicted or performed significantly better, as it has a lower root mean error square. Next, we evaluated on the test set. So we evaluated on both models on the test set. For the linear regression model, our output was for the error 4.5, and then for the random forest test model, we ended up with 3.25. And again, the random forest model was more accurate than normal linear regression. So as a result of this, we ended up selecting the random forest regressor as our final model due to its superior performance on both validation test sets.